Welcome back to a new data science project. In this video, we are going to train a deep learning model for image classification. We are going to have a data set about agriculture and we are going to have 139 different labels. So we are going to have a multi-class image classification problem. We are going to start with exploring the data and then we are going to train our deep learning model using PyTorch. And at the end, we are going to create a Streamlit web app for deploying our model and we are going to be able to upload pictures of the crops that we want to classify and we are going to be able to get the predictions from web. I'm going to be sharing the dataset that I'm going to be using in this video in the description. You can download the dataset from there. It's going to be a hands-on coding tutorial and we can directly start. This is the data card of the dataset that we are going to be using for this deep learning training project. And let's start by just looking into it. So it says plants and crops image dataset for agriculture. It says ready to use image dataset for agri AI and plant recognition. So instead of downloading our files in here, we are going to do a different thing and we are going to download a specific subset of this dataset. I'm going to show you. So let's just check this page and talk about it. Then we can talk about which file that we are going to be downloading. So at the first place, let's see. The popular 139 crops image dataset is comprehensive and diverse collection of images featuring 139 widely cultivated crop types. And it says each crop class contains approximately 250 images uniformly resized and stored in multiple formats and cover modes. Okay, that's enough. So we know that image sizes, image per class, total classes, we have the color formats, different options. We are going to working with RGB in here and we are going to have around 35,000 images for training, testing and validating our model. So let's continue. In here on the data explorer side, we see that we have different files like this. And in the link that I'm going to give, it's going to be automatically taking the RGB version. If it's not, you can just click on this. Like in here, we have the RGB file, and then we have like train, test, validation. You are just going to download this. You will say download on this, only the RGB. It's going to be around 1 GB. And we are going to be working with these files. So inside it, we have test, train, validation. We can see the different crop types like almonds, plant, crop. Then we can see the images like this we have, and I'm going to show you the file structure on my local computer instead of in here. So this is how you can download the dataset. Again, you are going to go to the data explorer, you are going to select the RGB and you will just use this download button on this. And after that, you need to put this file in the directory that you are going to run your Python code in this tutorial. Okay then, let me show you the folder and what kind of pictures we have. So here, I'm in the directory that I'm going to create my Jupyter notebook and Python file on. And you can see that we have this downloaded file in here, RGB 224 to 224. And the other files are not important, like intro and outro of this video, and the videos and the link of the dataset, they are not important. You are just going to have this on the project directory for the start. And let's go inside of it for just quickly checking it. We have the testing set, training set and validation set. And let's see some of them. Like we have different pictures for most of the plants. The common ones, we have 139 classes like buckwheat plant and dates plant, a lot of pictures in all files. Like let's go in the validation set and we can see we have different images for them. And let's go on the test. Like we have this, dry beans and blueberries, and great. So just want to make sure on that you downloaded the file correctly. You need to see this 3 sets on your file destination, and if you have those, we are good to start. And you are just going to have the file like this and you are going to create your Jupyter notebook in this directory. Great, let's continue with the code editor and let's start coding. I'm in the Visual Studio Code interface right now. You can use any code editor that you want. And here is the RGB file we have in here. And I'm going to create a notebook file like model training.ipmb. and we are going to be working with a Jupyter notebook. I'm going to create a code cell, and let's create with selecting kernel, and next we can run our Python code in here right now. So let's start with doing some imports. At the first place, we are going to import the operating system. Then we will say import matplotlib.pyplot as plt. We are going to say import random, and we are going to say from Python image library import image. And next, after this, I want to show you the Torch and Torch Vision versions that I'm using right now. I will say pip3 show Torch, and after that I will say pip3 show Torch Vision. So I'm using the 251 Torch and 021 on the Torch Vision. So if you want to make sure on the versions are matching and you are going to have all the codes in here working on you, you can just install the same versions. But any version after that is not going to be a problem in my opinion. So let's define the dataset path. So it's going to be dataset path, and it's going to be RGB, and let me quickly find that. Let me copy this directly like the relative path, and in here I will say like this. So we defined our dataset path. And remember, in here we have train, test, and validation. Sets ready. So let's start by exploring the data. We already read some of this from the Kaggle page. So what we are going to do is we will say train directory operating system path join, and we will say dataset path, and I will pass train, and in here we are going to reach to this training set in here. So next up I will say classes, and it's going to be list directory on the operating system with train directory. So if the dataset is not updated, we need to see 139 on the classes, but I saw something like version 5, so there's a possibility that a new data class added into the dataset. We will see right now. Yeah, we have 140 classes on the dataset, so they add a new label, and we can directly say classes for seeing all of them. And what I'm going to do in here is I will say random.sample, and I will pass classes with 5, so we can see 5 random class names like sweet potatoes plant, mustard green plant, artichoke plant, okra plant, and sunflower seeds plant. So let's visualize sample images. What I'm going to do is I'm going to define a function with the name show sample images, and I will say number of classes is going to be, let's say, defaultly 4. Next up I will say figure, and axis is going to be matplotlib subplots. I will pass number of classes 5, and we can pass figure size like 15. I need equal sign on there though. 15 and 3 multiplied by number of classes. And next up what I'm going to do is I will say for index and class name in enumerate random.sample, I will say classes, and I will say number of classes. So it's going to be dynamic, and whenever I update the number of classes when I'm calling this function, I'm going to be able to reach to the amount of images that I want. Next up I will say class path, and it's going to be operating system path join, and I will say train directory and class name like this. Next up I will say images, and it's going to be list directory class path is going to be, yeah. Next up I will say for j in range 5, let's say image path is going to be operating system path join class path like this, and we will say images, and we are going to take the index in here that we iterate. And next up we are going to say image is going to be image open image path, and we will say axis, and it's going to be equal to the I and j. Next we will say image show, and we will pass image like this. Next up we will say axis and I J again, set title. We will give class name like this, and again access I J, we will say access, and we can say off to this. And after that, what I'm going to do is I will say in the indent of the first for loop, I will say like plt tight layout like this. And let me make this function run, and we can directly call it like this with the default value of 4. So we can see it's a function main, and when I call this like that, we are going to have attribute error. Let me quickly check why is that. Here it says figure set, fixed size. Okay, I'm not going to put underscore, so let's just remove this, and it's going to be like this. I will rerun the function and I'm going to recall it, so we are going to have it in here. Great. After fixing the typo, so we can see that we have sample images right now, and when I rerun this, we are going to see different things since we are selecting randomly, and we can see random images like this with this function. Like, let me run it once again, and here we see dry peas plant, Brazil nuts plant, and caliber tail plant. So we got this here. Great. We have the 5 images or 4 different classes. This can be used for getting familiar with the dataset on computer vision projects. So let's continue with data preprocessing with PyTorch. So we will say import torch. Next we will say import torch vision like this, transforms as transforms, and we will say from torch vision datasets import image folder, and we will say from torch.utils data import data loader, of course. Great. Next up, we are going to define the transformations. Like transform is going to be transforms, and we will say compose. Then I'm going to say, like, let's go one by one like this, transforms resize, and we will pass 224 like this. Next up, we will say transforms to tensor, and we will say transforms normalize, and we are going to give numbers like ImageNet mean 0.485, 0.456, 0.406, and next up I'm going to give like 0. In here we are going to give the standard deviations 229 and 0.224 and 0.225 like this. And here we can make this run, and next up we are going to load our data right now. So for that we will say train dataset, and it's going to be image folder. Next up we are going to initialize it with path, and we will say join after path. Then we are going to say dataset path with train, and next up what we are going to say is transform is going to be the transform like this. Next up we are going to do the similar process for the validation dataset and the test dataset. So I'm just going to make a copy paste like this, and in here I'm going to change this like validation dataset, and I'm going to change this like test dataset. Next up what I'm going to do is I will say validation in here and test in here, so they are similar, right? Next up we are going to make this run, and we are going to say train loader, and we will say data loader like this, and in here we are going to pass the train dataset. And this is a really important point, like in here I'm going to say batch size, and the number you give in here is going to be really important. This is the number of samples the model processes before updating its weights during training. Instead of feeding the entire dataset at once, data is divided into smaller batches to balance memory efficiency and learning stability. So what I'm going to continue with is I will say 128. You can decrease this number like 64 or 32. I'm going to take 64 for validation and test datasets. It's based on your computer settings and the quality that you want to achieve. Like, you can change these numbers, and I'm going to continue with this. Then I'm going to say shuffle equals to true. And next up, I'm going to set number of workers as 8. But I recommend, based on your computer setup and computation power you have on your computer, you can go with 4. I'm just going to go with 8. And if it is not going to work on your case, you can just change this to 4 or change this to 64 or 32. It's based on your RAM. So I'm going to be running this setup with 16 gigabytes of RAM in an M2 MacBook Air. So let's continue with the validation loader, and it's going to be data loader. I will say validation dataset. Batch size for this I will say 64, and shuffle is going to be true. And for the test loader, I will say data loader, test dataset, batch size is going to be 64, and shuffle is going to be true on this one. Actually, I'm going to shuffle false these two and continue with that, because when we open the shuffle, it's just going to mix up the data every time. But on the validation and test loader, we don't want that. We want the model to evaluate on the same data in the same order every time. So since we are not updating any kind of weights on the validation and testing, randomizing the data order is going to give us nothing. So I'm just going to make it run. Now what we are going to do is we are going to build a CNN model, convolutional neural network, and we are going to use transfer learning. We are going to load a pre-trained model and train off that. So we will say import torch vision dot models as models, and then we are going to say import torch dot neural network as neural network. Next up, what I'm going to do is I will say device equals to, if you have a GPU, then it's going to be better for the model training. On Macs we have a different situation, but I'm firstly going to show you how we can do it. GPU, it's the best setup. So torch.device, we are going to say like CUDA, if torch.CUDA, actually let me fix the typo, if torch.CUDA is available, it's returning true or false in here. Just let me quickly show you. It's going to return false on my case. And next, else CPU is going to be our second option. So if you have GPU, then it's going to automatically switch on that, but if you have CPU, it's going to continue with that. Just want to show you that code too. And on Macs, Apple Silicons, we have different option. I will say torch, backends, MPS is available, and if you are running this code on Mac, you are going to see that with M series chips you are going to have this true, so we can use method performance shaders. So what I'm going to do is, instead of this, if you have GPU, you can run this on. I'm going to say device is going to be torch.device, and I'm going to say MPS if torch backends, this code here, backends MPS is available, and else situation is going to be the CPU again, like this. And let me show you the device right now. It's MPS. You can use this if you are using M series chips of the Apple. Okay, next we are going to load a pre-trained ResNet. So model is going to be models ResNet 18, pre-trained is going to be true like this. And let's have this ready. Next up, we are going to freeze early layers, like for parameter in model.parameters, I will say parameter requires gradient false. So we are going to replace the final layer. Number of classes is going to be length of the trained dataset classes. And next up, we will say model neural network linear. We will say model in features like this, and we are going to give number of classes. And next up we will say model is going to model to device like this. And here we use a pre-trained ResNet 8 in here. It's a lightweight and performs great. Then we freeze all earlier layers and only train the final classification head to adapt it to our 140 crop classes. Now we are going to define the training functions. So I will say import torch optimizer as optim and import torch neural network functional as f. Next up, what I'm going to do is I will say optimizer, and it's going to be optimizer Adam. I will say model parameters, and learning rate is going to be 0.001, and criterion is going to be neural network. We are going to use cross entropy loss. It's a multi-class classification problem, and this is nice on multi-class classification problems. Next up, we are going to define a function for training one epoch. So define train one epoch. We are going to be passing the model and loader in here. And next up, we will say model.train firstly. Next, we will say running loss is going to be 0 at the start for sure. Next, we will say for images labels in loader, images labels is going to be with comma like this, images to device, and we will say labels to device like this. Next up, we will say optimizer 0 gradient, actually like this, sorry for the typo, 0 grade, and we will say outputs is going to be model images, and loss is going to be criterion that we define in here, cross entropy loss, criterion, outputs and labels. And then we are going to say loss backward, so it's the backward pass, and we will say optimizer dot step. So at the end we need to add our loss in here. So what we are going to do is we will say running loss plus equals to loss.item, current loss. And at the end, for the function, we are going to be returning running loss divided by length of the loader. So this is going to be our function for training epoch. And next, we need a function for evaluation. We will say define evaluate, and we will pass model with loader. Next up, we will say model.evaluation mode, and we will say correct is going to be 0, total is going to be 0 at the start for sure, and we will say torch gradient updates. We will say for images and labels in loader, images labels again is going to be images to device and labels to device again. Next up, what we are going to do is we will say outputs is going to be model images, and we will say we can directly use something like this, and we can say like predicted, and it's going to be torch maximum outputs dot data and 1, and then we are going to add this to total. We will say total plus equals to labels dot size 0, and correct is going to be plus equal to predicted equals labels. This means that a prediction is correct, that's sum and item like this. So at the end we need to return correct divided by total. So here is our evaluation function. We are going to use this tool for looping through epochs and see how well our model is learning. So we can train the model right now. I'm going to set epochs like, let's say I'm going to use 5 epochs. You can increase this number for teaching your model better, and I will say for epoch in range epochs, it's going to iterate over this. We will say train loss is going to be train one epoch model. We will pass with train loader in here, and validation accuracy is going to be evaluate model validation loader and we will say print, like let's write a print statement, epoch +1, and we will say in here train loss is going to be train loss, like this. And also let's format this like floating points. And next, validation accuracy is going to be like validation accuracy float, like this. So when I make this run, I'm going to start training my model, and I think it's going to take around 15 minutes. So when this finishes, I'm going to be re-recording. So let's start it, and it's running as you can see. And when this finishes, I'm going to be re-recording with the results in each epoch, and it's going to report us the train loss and validation accuracy. Okay, here we trained our model, and between epochs you can see the difference on the validation accuracy and train loss. Like our loss decreases with epochs and accuracy increases. Like it started with 0.34, then 0.40, 0.42, 0.43, 0.45. If I just set this epoch number to 20, 50 or 100, it's going to be a lot better on accuracy side, but I'm not going to do that in this tutorial since 5 epochs took 18 minutes. I don't want it to be longer. So what I'm going to do is I'm just going to use the model with the accuracy of 0.45. If you want to have a better model, you can just increase this epoch number to something like 10, 15 or something like that. So let's see the test accuracy. So test accuracy is going to be evaluate, and we'll pass model and test loader, and we can just do a print, like we will say f-string test accuracy is going to be like test accuracy is going to be for float, and we are going to get our accuracy in here. When this finishes evaluating the model, it's 0.4528, so it's similar to the validation accuracy. Great. The model never seen this data before, and accuracy on that side is 0.45. So let's visualize the predictions. I will say define, visualize, predictions, and it's going to be model, loader, and n is going to be 5 defaultly. Next, we are going to take our model to the evaluation mode, and we will say images shown is going to be 0. Next, we will say class names. It's going to be train dataset dot classes. And next up, what I'm going to do is I will say with torch, now gradient for images labels in loader. I'm going to say like images to device, like this, and outputs model images, and I will say like predictions is going to be torch max outputs and 1, like this. Next up, I'm going to write a for loop inside the for loop in here, like indent is going to be under this for loop. I will say for index in range of n, the defaultly passed 5. I will say image is going to be images I CPU permute, and what I'm going to do is I will say 1, 2, 0 and numpy, like this. Next up, I'm going to say image show image multiplied by 0.229 plus 0.485 for unnormalized. Next up, I'm going to say plt.title, and I'm going to give a title like true, and class name is going to be the class names, and I will say labels I, like this. And next up, I will say prediction, and this is going to be like class names and predictions, and I, like this. And next up, in the next line in here, I will say plt access off and plt.show and we can just add like this images shown count plus equals 1. And next up I will say if images shown is greater than or equal to n, we will say return like this. So this is going to be our function in here, and I'm going to make it run. We take the model to the evaluation mode, image shown count, class names here with torsional gradients. We say loader, iterate over it, we get the outputs and predictions, then we visualize them. So let's call our function right now. I will say visualize predictions, I will pass model and test loader in here. Also, I don't want to use it with default 5, so I will pass 3 instead of this, and I'm going to make it run. And here we can see the predictions. So let's see, true label was a pepper plant and prediction is habanero pepper plant. We are wrong on this side. True is a pepper plant, predictions is a pepper plant, so we are correct on this. True a pepper plant, predictions a pepper plant, so we are predicting this correct too. So on the first 3 images of the test loader, we predicted 2 of them true. Great. It's a great guess, by the way, for 139 classes, so I'm happy with this performance right now. Again, if you just want to increase the accuracy, like let's say you want to predict everything perfectly, it's not the possible thing in my opinion, but you can just try to achieve that by increasing the epoch in here. Also, you can decrease the batch size from the upper side. So we have our predictions and everything ready in here. In the next step, what we need to do is we are going to export this model. Like, let me open the file directory right now. We don't have any kind of model files in here, and the model is only in the runtime of our notebook, which is a huge problem. Because if we don't export it and just close the VS Code or just close the computer, we are going to lose this model right now. So what we can do is we can save this model's files for using it later on. So for that, we are going to import joblib. And next up, what I'm going to do is I will say model data is going to be, I'm going to create a dictionary. Model state dictionary is going to be model.state dictionary like this, and class to IDX is going to be train dataset class to index like this. So I'm going to make it run. We have the model data in here right now. Next up, I'm waiting for it to run. I'm going to show you how we can export the model data. So here is the weights of our model. Like, we can see the tensor and we can see the weights, all of that. So if we export this and load that back in another app, then we are going to be able to use the same model like this. So let me just quickly clean this output in here, and I'm just going to click on that. We have the model data in here. I will say joblib.dump, and model data is going to be the thing that I'm dumping, and I will say crop classifier model.pickle like this. So I don't have any file in here like a pickle file. When I make this run, I'm going to have crop classifier model.pickle in here. So I can use this whenever I want in my apps right now if I load it back on the app. So let's just quickly talk about what we did in this Jupyter notebook. Then we can move with the Streamlit app creation. So we make our imports, we define the dataset path, train directory, we check the number of classes, we check the classes. So let me just collapse that. We visualize the sample images with the function, and we import torch and stuff. We create transforms, we load our data in here, then we define device, like I defined MPS on Apple Silicon, and we got the ResNet 18 in here. Next up, we just froze the first layers. We are just updating the last layer in here, and we created the training one epoch function with evaluation function. Then we trained our model. Again, you can increase this number for better performance. We checked the test accuracy, we visualized the predictions, and next up we checked our predictions and we exported our model. So our job with the Jupyter Notebook is done right now. I'm just going to save this and I'm going to create a file like crop classifier.py like this. It's going to be a Python file for making it run with Streamlit, and we can directly start coding our Streamlit app right now. So let's start with doing our imports. Firstly, we will say import Streamlit as st for sure. It's going to be a Streamlit app. We will say import torch vision dot transforms as transforms like this, and we will say from torch vision import models, and we will say from Python image library import image, and we will say import joblab, and we will say import io. Okay, these are going to be our imports. Now at the first place, what we are going to do is we are going to load the saved model. So it's in here. I'm just going to copy its name, like copy relative path. Then I will say in here, model data is going to be joblib.load. I will just pass it in here, and we are ready to use this model in here. Next, we are going to load the ResNet and set the state with our state dictionary. So model is going to be models ResNet 18, and pretrained this time is going to be false, since we got all of the weights of the model. And next we will say torch neural network linear, and we will say model fc in features, and we are going to pass length model data, and in here we are going to give class to idx index like this. And next up, what we are going to do is model load state dictionary and model data model state dictionary, and at the end what we are going to do is we will say model.evaluation mode for getting predictions. So here everything is ready for using the model. And next up we are going to reverse class to index mapping in here. So we will say index to class, and it's going to be like v k for k v in model data class to index like this. And next up, actually we need to say items to in here, and it's going to work fine right now. We are going to create transform, and it's going to be the transforms.compose, and we will say transforms.resize 224 to 224, and next up we will say transforms to tensor, and we will say transforms normalize, and I'm going to just enter the same numbers with the previous one we used 6, and again I will say 0.229, 0.224, and 0.225. Yeah, like this. So after this, it's going to be ready to get used. So let's start building our app right now. We are going to say Streamlit title, and title is going to be the crop classifier. And next up we are going to say Streamlit markdown, upload the crop image, and the model will predict which crop it is like this. Next up, what we can do is we will say upload that file, and we are going to use Streamlit file uploader like upload an image, and we can specify the type in here. Like we need to pass a list in here like JPEG and like this. Actually I need quotes around that. And next up I'm going to say PNG like this. Great. So next up we need to say like if uploaded file is not none. So if user uploads a file, we will say image is going to be image open, we will say uploaded file, and we will say convert, and we will pass red, green, blue, RGB. And next up we will say Streamlit image, we will pass image, caption is going to be uploaded image, and we will use container width, and it's going to be true like this. Next up I'm going to say input tensor, and we are going to do the pre-processing with this. So I will say transform image, and I will say again squeeze 0 like this. And after this, we are going to do the prediction with torch, no gradient. Output is going to be model input tensor, and predicted in here is going to be torch max output with 1, and class name is going to be index to class predicted item like this. And for the final part, we can directly say, like, not in this indent, but if indent Streamlit success predicted crop, and it's going to be an f string like this, predicted crop, and we can just do like class name like this. And let me find the emoji for title and success message. Give me a second. Yeah, here it is, just found that. So I'm just going to put this in the both sides, and for the predicted crop I'm just looking for another one. Yeah, great. So I have those two. Now our app is ready. Just so that I have a small typo in here, and also I'm going to use brackets instead of parentheses in here. Like, let me quickly add this. So right now it needs to be running smoothly. And what I'm going to do is I'm going to open my terminal. I will say Streamlit run crop classifier.py. So when I make this run, it's going to be opened in the localhost address in here on my browser. If it's not automatically opened up, you can just copy this local URL address, starts with HTTP, and paste it on the browser for reaching to the website that I'm going to show you in a second. And these depreciation warnings are not important. Let's forget about them, and I'm going to be re-recording in this address in a second right now. So here's the app that we just built, and we can just change the settings like light or dark theme or white mode, not important, I'm not going to play with them. And I'm just going to upload pictures of the crops that we have on our testing data, validation data, training data, and let's see the predictions on that side. So for the start, I'm going to upload a picture of an almonds plant, and let's see our prediction. It says almonds plant as predicted crop. Great. So our model successfully worked, and also our web app is working perfectly. I'm just going to delete this file right now, and let's make another prediction. I'm going to upload an image of broccoli plant, and let's see the prediction in here. It says predicted crop is broccoli plant. Great, this is correct too. So in here, I'm going to upload a cinnamon plant in here, and let's see, it predicts cinnamon plant. So here, for the third prediction, we got it right, and our app is working perfectly fine. Like when we upload the image, it just directly shows it in here, and it shows the prediction. Okay, this is working perfectly fine, and right now I'm going to be re-recording on the code editor for summarizing the app that we created. Okay, in here I can directly close the terminal, and we imported the libraries that we are going to be using for this app, and we uploaded the model data in here. Then we created the RiskNet initialization again with pretrained false options, and in here we defined the transforms and index to class transformations. I already talked about this model loading part, so I'm skipping it. We give our app a title, we create a markdown as upload a crop image, and the model will predict which crop it is. And here we have the uploaded file in here. Set it up on the Streamlit file uploader with the types of GIF and PNG. Next up, we say if there is an uploaded file, by uploaded file is not none, we say image is going to be image open. We convert it to the RGB. Then we use streamlit.image. We just pre-process the input tensor. We get our prediction, and we give our prediction with success message from Streamlit. That was the project that we are going to be doing in this video. Let's get to the outro. Thanks for watching this project. I have a data science and machine learning projects playlist where I have more than 40 videos just like this one. You can reach that playlist from the cards of this video or from the links in the description. Also, I'm sharing a new data science video every week on my channel. You can subscribe for more videos. Have a great day.